this is my Lab 3 on black hole and orbits. So an introduction. So first of all, the purpose of this lab was to determine the mass of a black hole from the movement of a star orbiting it, and then determine the velocity required to send a ship into a figure 8 orbit around a moon and a planet. So some models and fundamental principles used were Newton's second law and universal gravitation. And just for a preview, the average mass of the black hole was found to be 7.98 times 10 to the 33 kilograms. The moon's orbital speed was 2.4404 times 10 to the 4 meter per second, and the moon's orbital period was 64.3663 hours. So the fundamental principles used. The first one was Newton's second law, which states the force acting on an object is the product of mass and acceleration. And if you extend that further, we know that the net force is equal to the change in momentum over time, and that is also equal to the net force parallel plus the net force perpendicular. And then if you substitute everything out, we know that the change in momentum over time is equal to the change in momentum over time parallel plus the change in momentum over time perpendicular. And then we can also extend Newton's second law to the position update, which just states that the final position is equal to the initial position plus the velocity times change in time. And then also the velocity update formula, which states that the final velocity is equal to the initial velocity plus the net force divided by the mass times the change in time. And then we have universal gravitation, and gravity is the force of attractions between any two objects with mass, and that equation is the force of gravity is equal to negative g, which is the gravitational constant, times the mass of the first object and the mass of the second object, divided by the magnitude of r, and r is the distance between the two centers of mass, squared. So part 1, we focused on finding the mass of the black hole. So the force of gravity of the black hole on the orbiting star is the perpendicular force, so they can be set equal to each other to solve for the mass of the black hole. And if we can see to the right, or is just some of my various code, the top box is the initial conditions that we set, and the bottom part is using momentum to solve for the mass of the black hole. This is another continuation of my code, which includes the final calculation of the actual mass of the black hole, and then the bottom half of that is just the code to plot the visualization, which is as seen. Obviously, it's just a picture, but we had a whole visualization of the different arrows and the different lengths over time. So for part 2, the computational model includes the universal gravitational formula, not force formulas, and Newton's second law to visualize the motion of a planet and spaceship. By changing the initial velocity of the ship, we can figure out a velocity at which the ship can escape being sucked into the black hole. So we can see the initial conditions set for the spaceship, which I found to be negative 2.1 times 10 to the 4 meters per second in the x direction, and then in the y direction to be 4.2 times 10 to the 4 meters per second. And then below that is when we began our calculation loop, and the first part that is shown underneath the while loop is the calculation of the net force on the moon. And then the top box is the calculation of the net force on the ship, and the bottom is updating the velocity and the position. And that is how we were able to find the period and the speed that was shown in the introduction slide. So some of the additional questions that we had, the first question for what does it mean? So in circular motion such as orbit, the net force in the direction of the motion is responsible for the change in speed of the object, while the net force perpendicular to the motion is responsible for the change in direction associated with the circular motion. Since the only force in part 1 was the force of gravity and it was perpendicular to the motion of the star, the mass of the black hole was able to be determined by analyzing the motion. And for our second question, you would have to include the changing gravitational forces between all the masses simultaneously as they move, which might be enough to cause our coding site to crash. The larger masses would exhibit greater forces of gravity on the other masses, possibly pulling them towards the largest mass, like in this case of black holes.